everybody. Paul Taubman here with 9.Connects. Thank you so much for joining me here today. For our customers who have joined us for many of our webinars in the past, thank you for coming again. And for those who are joining us for the first time, we hope that you like what you'll see, and we'll see you in the future. We are 9.Connects, and just very briefly before we get into our navigating Altium, I just want to talk about who we are. We are the exclusive trainers for Altium North America, so we do work with Altium. A number of us are not only certified in Altium, a number of us actually wrote materials for their training as well, and we're also IPC CID certified. So if you're getting any calls from Altium to do some training, I would say it's a very highly likely probability that we're the ones who are going to do that training for you. In addition to that, we do design consulting. So if you really do need some help with any of your designs, feel free to give us a call. We're here to help you out on that. And it's not just us analyzing it and throwing a report at you. It's really us working hand in hand with you so that not only do you get the design done, you're going to learn something from it as well. And then lastly, we obviously do printed circuit board layout stuff, everything from RF and high speed and everything in between. We can also review boards for design for manufacturing, and we can go the gamut. We are a very PCB-centric organization. That's where our expertise lay. And that is all I'm going to say about 9.Connects, and now let's get on to the good stuff here. So I'm going to hit Escape, and we'll jump on over here to Altium Designer. So I wanted to start with this particular screen to begin with because this is probably somewhat of what you're dealing with when you're new to Altium and you don't really know what to do or where to start. And as a matter of fact, if I go over here into the View window and I click on Desktop Layouts and go to Default, it may actually look more like this. So let's bring this back up over here. In fact, it defaulted everything back to Monitor 1. All right, there we go. And so what you're seeing over here is what they call the Storage Manager panel. And you may also see this thing called the Files panel. And the reason why Altium put that out there to begin with was to give you a feel for what's available to you. All right, and most of the time, I'll be honest with you, I probably never use this. It's one of the first panels that always comes up, and I probably never open it thereafter. I'm going to talk a little bit more about panels as we move along here. But what I wanted to show you here first and foremost is that it's okay to close a panel. Sometimes people get a little weary about closing them. In some tools, you close them, and you really can't navigate. But let's start from something as simple as this. How do we get a project into something that doesn't really have a whole lot going on the screen over here? How do we make this whole thing kind of sing and work for us? Well, before we even do that, what I want to do is I want to show you something in the operating system because I think it's an important aspect of it. So I'm going to bring up my workspace folder here, and I already jumped to the good stuff here, but let me jump over here to Altium itself. So let's talk about how Altium installs things onto your system. In a typical installation, it's going to put it in the Program Files directory, so it's going to use the x86 because it's still a 32-bit program. They're working on making it 64 bits. It was built in Delphi. And because of that, though, it gave them, I think, a big leg up on the graphical capabilities, which makes Altium a very, very powerful tool. Unfortunately, Delphi has not really kept up on the 64-bit capabilities, so they're moving over to C#. So I'd say probably in about another year or two, we may see Altium as a 64-bit program out there. But for now, it's still a 32-bit processor, or pardon me, 32-bit software, and it puts it under the x86 program files. Now, if you've been around for a while, you know that pretty much any software that installs in there, in the past they would also install all their libraries and all their examples and all the other good stuff that they would provide to you. But then after Windows 7 came about, actually maybe even been Windows Vista, then this UAC came about, and the UAC basically says, look, you can install your program over here, but if you have any user interaction in that directory, we're going to block it. And so what Altium did was they said, okay, we're going to give you the option to put it in another location. And by default, Altium will usually put its examples in a public documents directory. And even if you have your own laptop, it's going to create, there is usually a public documents directory along with your own personal documents directory as well. Now you can see over time I've collected a couple of these. I don't think I have all of them installed, but every time I've installed Altium, it gives me a new examples directory here. So I just recently installed Altium Designer 16. And I'm going to click into that here, and we'll take a look. Now, there's a few extra things in here you will not have with this. In fact, one of them I'm going to remove, which is my workspace. So I'm going to recreate that at the end of the project here when we talk about subversion. What you're going to get are 3 files. One of them is an example file, a bunch of examples. You're going to get the library, and you're also going to get the templates. So the Bluetooth Sentinel and the repository, Those are things I've set up, again, to talk about subversion. But what you're going to see are these three: example, library, and templates. I don't have a lot of time to talk about the templates right now, but you can see all the different templates that they provide, everything from schematic templates to PCB templates for very specific types of designs. They also have bill of material templates. It's something to certainly take a look at. The libraries one I'm just going to mention here very quickly, because anybody who's new to Altium, this is a point of confusion, and I think it's an important one to kind of address. Altium no longer provides PCB libraries with their installation. In the past they did that. The last time they did that was Altium Designer Summer '09. Obviously that was in 2009. And since then what they did was they created what's called an online content vault, which you can access through Altium Designer. As long as you have subscription to it, if your subscription is up to date, then you can basically get those library components from Altium. And that's actually a very good thing, because in the past, Altium could never really keep up with all the updates on their libraries, because they could only provide a library update if they did a software update. So by basically giving them their own, let's say, content vault area that's separate from all the updates on the software, they have designers who can put out more basic library components on a daily basis rather than have to wait for another software release in order to provide those additional library parts. So that's where they're all located. The only two libraries that they will give you of a PCB nature are miscellaneous connectors and miscellaneous devices. The rest of these that you see over here are generally related to FPGA and OpenBus. If you're interested in SPICE, they do have a pretty good simulation library here. So Altium does have the Berkeley SPICE engine built into it as well. But that's the only thing I was going to mention about the libraries. And I think the only reasons why they even give you these two libraries here is that if you ever pick up a tutorial, it just makes it very easy for them to get the tutorial up and running without you having to try to get a library installed in it. Okay, where I want to focus here is on the examples. And on the examples, obviously these are going to be projects, and in these projects they're going to try to show you some capability or feature of the tool. And the Bluetooth Sentinel, which is their what I'll call flagship example, is no exception to that. So if I go into the Bluetooth Sentinel, I want to show you a few things. Now, one of the things I want to show you, and I think this is really important, is this need for you to turn on a few things that the operating system turns off by default. So this, I believe, started in Windows 7, and it's happened thereafter. And one of those things that happens is that by default, the Microsoft operating system has something that's called turn on or turn off extensions for known file types. And so if you load a program on there, it registers with the operating system, and it says these are the extensions I'm going to use. And since those are now known file types, then the extensions are no longer shown. And that's okay for a Word doc or for Excel or even for a PDF, but in Altium Designer we have a number of different file types. And as a result, if you don't have these two things turned on, you will not see all of the extensions. So if you're using Windows 8 or you're using Windows 10, make sure you go to the top ribbon where there's a View tab, and then you can turn on file name extensions, and it'll turn it on even though it's known. And then the other one I recommend is hidden items, because things like subversion or even this little preview folder that Altium keeps over here now come into view. Now if you're a Windows 7 user, it's slightly a little bit different. Let me bring this picture up here for you so you can see it. I don't have Windows 7, so I was able to find this online. You got to go into your folder options, and you'll click on the View tab there, and you'll want to turn this off where it says Hide Extensions for Known File Types. Okay, you'll turn that one off, and then once you see the hidden folders, you got to change the radial. You don't even have to scroll down. It's really what you see over here is immediately what you can do to change it. So I just want to bring that up for those Windows 7 folks who are still lucky enough to get to use it. All right. Now, in addition to that, the reason I want to bring this up is that there are a number of folders, or actually not folders, but a number of different files that we have to work with in Altium Designer, and you can see there's quite a few of them. There are really three major ones that we need to know about. The other ones are what I'll call ancillary. They certainly help. They do provide information. But in the end, there's three major ones that we need. The first and foremost is this one called the PRJ PCB. That is one that we've got to have. All right. If we don't, we can work without it, but in the end, they become free documents, and we certainly cannot really create or generate manufacturing files without it. The second one that we obviously need are the schematic doc or schematic docs. So you can always have more than one schematic document. And then we also want to have a PCB doc. That's our PCB. Can you have more than one PCB in a project? Yes. Do I recommend it? Absolutely not. And the reason why is because one of the powerful features of Altium Designer, and we're going to see this later on when we talk about the navigation tool, is that there's a very bond between the schematic and the PCB. So as long as we have our schematics and we have one PCB, Altium Designer can maintain the netlist integrity between the two of them very easily. And if we don't have that, or we have multiple PCBs, it gets kind of confused. Now the PRJ PCB, if we want to get a project going, I could simply double click on this and then Altium will basically populate it and we'll see it. But the reason I don't want to do it this method, and it's the easiest method, is I want to show you another way to get to it if you need to. One of the tricks that I've kind of learned over time when I'm dealing with what they call the Windows Explorer, so there's Internet Explorer and I think there's a new Microsoft Edge, but this is actually called the Windows Explorer, is I click once into this path window and then from there I'm going to do a Control-C. So now I know where this path is located. I'm going to minimize this here for now. If I'm back in Altium Designer, I can go to File, and I've got two options. I can either do Open or I can do Open Project. And really the only difference between the two is that with Open Project, it's going to filter out everything except for the .prj PCB. So I can find it very easily. But just to show what it looks like when we do Open here, I'm going to click on Open. I'm going to click here because I don't know if it's going to put me in the right directory. I'm going to do a Control-V to drop it in. And usually, by the way, by default, when you start Altium Designer, it always points you to its examples directory. I'm going to hit Return, so I guess it was there. That's fine. And then I'm going to click on the PRJ PCB. Note that I don't have to select anything else. So just the PRJ PCB, I'm going to bring that in. And now we see the Projects panel pop up, and along with all of our files that are associated with this particular project. Okay. Before we get into the project itself, let me talk about these things called panels. So panels are there to help you. They're very much like dialogues. However, the difference between a dialogue and a panel is that when you're in a dialogue, you cannot do anything else in that system until you either press OK or you cancel it out. Where a panel is always available to you to help you find things, search for things, and so on and so forth. And there's probably about 30 different panels in Altium. So what can we do with them? Well, right now this one is docked. Okay, so it's off to the side. We do have a little thumbtack over here where if we click on it, we can pull our cursor away and it will slide in. So if I want more drawing space and I don't want to always close and open the panel again, I mean at least dig it out of the panel collection. I'll show you that here in just a moment. Then I can just basically have it off to the side. If I put my cursor over it, it pops it back out. And by the way, there's even ways to adjust the speed in which it pops out if I want to do so. And I can lock it down. All right. If I also want to, I can move it about. I can grab it, so left mouse click on the top bar here where it says Projects, and as I click and drag it out, I can now make it a free panel. I can move it wherever I so see fit. I don't know if you can see this, but in the center there are 4 icons showing each of the directions. You may not be able to see the icons, but you can see that if I put my cursor over one of them, it pushes to the left, saying this is where I'm going to place it, or to the top, to the right, or to the bottom. Some of these panels are very good vertically. Some of them are very good horizontally. This is an example of it being docked to the top. I don't think it looks that good docked this way, but there are some panels that look like spreadsheets which work much better in a vertical fashion. In addition to that, I can open up other panels. Where are they located? There's 2 places I can find panels. I can always go into the View menu, and I can go into, for example, the Workspace panels here. And in the Workspace panels, I can see all the ones that are available to me here. And these are all the panels that I can grab if I want. They're also available for me in the bottom right corner. So if I go under System, for example, I'll see all the panels that were just available to me also as you saw in the menus. So I'm just going to pull up one here for now. I'm just going to take the output one. Okay, I rarely ever use it. And that's one of the things you're going to find with the panels in Altium Designer. There's about a half dozen of them that you'll always want available to you. The Projects panel is probably the most important one out of all the panels. Some of them you may never use. You'll look at them and, okay, that's nice. Sometimes you'll occasionally use them. Like the Message panel, obviously I'll use it, but I'm only going to use that when I'm compiling. I don't generally keep it open. So what can I do with the output panel here? Well, I can do a couple of things. I can stack it in here. So now I've got 2 tabs here on the bottom, one for Projects and one for Output. And if, by the way, if I take the whole thing and I dock it here, they're both still here. Okay. And if I want to pull the output one out, I can simply just click and drag on the bottom tab and pull it out. And you can play with this all you see fit and all you want. I think it's a good thing to learn how to move these panels about. Sometimes they get a little persnickety, and you just want to have control over them. But again, don't worry about if you accidentally close one or if you moved it in a weird and odd way. That's kind of half the fun with these panels here. The other thing I can do with these, I can do what I call glum them together. So if I bring the output panel over here, you'll notice, I don't know if you can see it, but there is a right icon, and I'm going to click on that, and now these two are actually attached to each other. So I call it glumming. I don't think that's an official Altium term, but I can do that in order to bring them together. More often than not, they will tend to glum to each other when they're on the side, so the big question is, how do you pull them apart? You simply hold down your Shift key, and then you will left mouse click on the one that you want to pull out, and then you'll separate it out. Okay, so that tends to happen on the side here every so often. It may even happen in today's webinar. We'll see. I'm going to close this one out. Now, if you want to get back to something that you know, or you want to set up your own, you can certainly do that. We're going to go back under View, and under View, you're going to see a few things here. You're going to see Desktop Layouts. You can do the default one. This is the factory default one. You can use that, or you can do the startup, which means this is the configuration you left it off before you closed the last time you used Altium. You can also do a load and a save. So if you want to save it in a configuration, you can, and then you can load it back in later on. So don't be afraid of the panels. That's the key thing. If you do something where you blow them all away, you know, let's say I just blew away my projects panel, I can always go back to System here, find my projects panel, and it'll bring it back up. It doesn't close out the project. All right, with that being said, let's talk about the project itself, and I'm going to open one of the schematic documents. How do I do that? I simply click on one of them that's available over here. All right. The project itself, there's a couple of things that we can learn from the projects panel. I'll pull it out just a little bit further. Hopefully you guys can see this. First and foremost, there are two different types of projects I can have in Altium Designer when it comes to PCB. One of them is known as the flat. So it means that any of the ports that are going off of one schematic sheet are seen by all the other schematics. The other one's called hierarchical. And I can tell that this is hierarchical by the fact that there are indentations in here. Okay, so I can tell that. And also when I look at this, we have something that's called a sheet symbol. And a sheet symbol, and let me zoom this in here a little bit. We'll talk about zooming here in just a moment. But I can tell that because what I can see over here is I have a representation of one of my schematic documents, and all I have are my ports. I don't see any of the guts of it. Okay, and so I can tell that this is hierarchical, and I can tell that the top level is being represented by the schematic sheets that make up this particular design. Okay, I also see some recycle symbols here. So what's the deal with that? So there are two different ways to reuse sheets in Altium Designer. If you have a vault, you can set it up so let's say you have an important power supply design, and every time someone does a particular type of project, they are supposed to use that design because it's been verified and well reviewed. Well, they could pull it down from that vault and it will show as a read-only. As a matter of fact, this project was done in Altium's internal vault, and that's why we see the read-only of this as a result of it. Now, do you have to have a vault for this? The answer is no. The other feature that they've got is something that's called the device view. So in fact, if I go into place here, I'll just bring it up so you can see it. I don't have any device views, for example, but the idea behind device views is that you could, again, take schematic sheets that have information that you know is really critical or you want people to reuse. You put them in a directory where they'll be where they will reside. You don't have to use a vault. You don't have to use a repository. And then what you will do is you will go to Preferences and tell Altium where you're keeping these device sheets. And then from there, every time you click on that, go to Place Device Sheets, it will list all those sheets that are in that particular directory. And when it places them, they will be in a read-only mode. So those are the two different ways that you can do a read-only sheet within a design. So if you see that recycle sheet, that means that it was being reused from some type of template that individuals have put together. And I'm not just talking about the template. Let me do a view fit, actually a view document. I'm not just talking about templates in terms of the grid or the title block. I'm talking about a template that actually has components in it and some logic to it. So, okay. Before I continue on to how we navigate through this particular project, what I want to talk about is the ability to just basically get around a sheet. And if you think about this for a moment, it's really interesting because there's actually a commonality no matter what type of tool you are opening up, especially any type of drawing tool. What is that commonality? First and foremost, we got to somehow get it loaded. Then we always have to get a license for it. Then we somehow either have to open the file in its native language or import it in from another language. And then lastly, once we have it up on the screen, we got to somehow have to navigate it. And that's what we need to do here in Altium Designer. And Altium Designer has a number of different ways to zoom. and to do panning and so on and so forth. And as a matter of fact, if you again go back to the general idea of this whole concept of looking at something in a program, what do we want to do specifically? We usually want to zoom in, we want to zoom out, we want to kind of get everything to fit the screen again, and we want to pan. Those are the four big things. And in Altium Designer, they do it in 4 different ways. If you like hotkeys, they've got ability to do that. If you like using your mouse to zoom out and pan, you certainly can do that. And also there's a lot of menu clicking that you can do as well. So I'm going to show you a couple of ways to do it. I don't use all of them. In fact, there's a lot of them. The only time I ever look at them is when I'm helping out on a training. But there's just a number of different ways to do it, and that's what's one of the powerful features of Altium. Excuse me. Okay, let's go up here over to the View menu. And you'll notice that pretty much half of this menu over here has to do with some ability to zoom in or out. And in here, you can obviously select it and it will perform that function. Some of them are driven by cursor movements. Others will just zoom in. Like if I click on 400%, it'll zoom me in 400%. I'll do a VF here, and I'll talk about that in just a moment just to make this fit again. In addition to that, you will notice, and hopefully you can see it, that there is an underline under the word View. And if I click on that, you'll see underlines under other commands here as well. Those are hotkeys, and that works for pretty much any of these things in here. So for example, what's nice about the hotkeys, I don't always have to drag my cursor to the top left corner. I can have the menu come to me and my cursor. So if I hit the V key on my keyboard, that menu just came to my cursor. And anything that's listed in there that's underlined, if I hit that, it's going to execute on that command, or it's going to bring me to yet another sub-menu. All right. So the two that I use quite often is I'll use the letter V followed by the letter D. That's fit. So it's View Fit Document. So VD will fit document. And then there's also VF, which will View Fit All Objects. So just to demonstrate this here, if I do a VD, which I hit the 2 keys, it now zooms me out and I see the entire document. If I do a VF, it just zooms me into all those primitives that are on my document. And sometimes if you got a really full sheet, there's not much difference between VF and VD. So that's one way that I use in order for me to fit the design onto the sheet. Now, in terms of zooming in and zooming out, there's, again, things you can do in the menu here. You can click on this each time. You also have various little icons that you have here. The two that I tended to use quite a bit is the page up and the page down key. Okay, and we can see that here. And by the way, if I go back into the View menu, you'll notice that it's for zoom in, zoom out. On the right side, if they've given it a hotkey, they'll tell you what that hotkey is. So you can see that when I hit the page up key, I will zoom in. So I don't have to hit the letter VI every single time, letters VI every single time in order to page up or pardon me, to zoom in. Okay, so I just hit my page up and page down. So that's one way to do it. The other thing that I can do too is I can scroll. In fact, I've got my mouse set up so that if I just scroll, I can zoom in and out. And the scrolling is based off of where your mouse location is. Okay, so if I pull out here and then I start zooming or scrolling up here, you'll see it's zooming based off of where my mouse is. By default, Altium is not going to just let you scroll. You have to actually change that in the preferences. Otherwise, you'd have to hold down your control key. I'm going to show you guys how to change that, so if that's something you want to do, you can certainly do it. Under DXP, we're going to go to Preferences, and I'm going to go under the Schematic section, or Schematic folder, and there is a mouse wheel configuration. So if you, by default, you'll see a little checkbox next to the control. Go ahead and just turn that off or make one of the other ones, give the check there. Now, if you happen to remove all the checks here, if I removed all the checks over here, it would still work. It won't complain about it. It's just the zoom main will take the precedence, and then the vertical scroll will be ignored. Okay, so that's how Altium kind of works that there. But I do like to have the vertical scroll as control. And so I just removed all of my checkbox there, and that's what allows me just to scroll without holding down any additional keys. Obviously, I do have a scroll bar here as well, so that helps me out tremendously. Lastly, for panning, the panning is simply a matter of right mouse clicking, and when you right mouse click, your cursor is going to turn into a hand icon, into a hand cursor. It's not an icon, a hand cursor. And then I just simply need to move the cursor along as long as I hold down the button. So that's how I get to navigate the screen here. And as I mentioned, there's so many different ways to do it. At some point, you're going to come up with your own ways and means of doing it. Now, if you are dead set, and I have to admit, after doing Altium so many years, I tend to get dead set in my ways of doing it. If you're using another tool and you're struggling because, look, in this other tool, I always zoomed in this way or that way, I don't want to get into it too much for now, but there are ways to customize this. So you can right-click here, and you can click on Customize, and you can create certain keyboard commands or override existing keyboard commands so that you could navigate it so you have the same look and feel of another tool that you're more familiar with. So you have my sympathy because I've been working on the E3 tool from Zukin, and I'm very used to the page up and the page down key, which gives me another page that doesn't zoom me in or out. So I have to get acclimated to their zoom in, zooming out system. So that's the way to zoom and pan. Let me hit the VF to get this back into the center here. Now, obviously, zooming around a page is a nice thing, but I need to navigate through the entire design. So how am I going to do that? Well, one way I could obviously do is I could follow what I've got written here. So this schematic sheet, for example, is the accelerometer, and I can go dig through my design here and try to find that accelerometer SCH doc here, or I can have Altium find it for me. So if any time I want to follow something here, it's just a matter of holding down my control key and double-clicking into it, and boom, it'll jump me to it automatically. If I want to go back up to the top, I just need to click onto one of the ports here, so I'm going to do a Control-C again, and it jumps me back up. One of the nice things it does is it shows you where it jumped you up, so it kind of faded out the rest of this in the background over here. And if I just click basically off of the screen here in the blank area, it should restore it. If it doesn't, for whatever reason, sometimes some of the maskings, when you do a select, don't restore it. You can always hit the clear button at the very bottom right-hand corner here, and that will clear it as well. Okay. Now you'll notice something here. It seems like we have only 3 signals going between the accelerometer and the processor, and or between everything here. Looks like there's 3 signals. So Altium has several ways of sending signals from one place to another. They can obviously send the classic signal through a port. They can also even do it through, in this case over here, they did this. We have power ports, and you can see they're using a power port. It's a special type of component. It's a primitive. And this one is available for, if you put it down, it means it's global. Okay, so you can send power port. You can have a port that's representing power information. You can have a port representing signal information. You can also have the classic bus port. So if you have an address with 32 lines, you can have a prefix that says address, and then you can index it, and you can do that as well. But what's really nice about the harness tool, and let's jump back down here again, is that the harness tool allows me to maintain the names that I give it over here, and I just basically bundle up those names and send it along on its merry way. Okay, and what's also nice about this is once I've created this harness here, if I'm going to place this down somewhere else, I simply need to go into the Place menu, go to Harnesses, and then I can use the predefined harness connector because it stores that information. It figures, hey, look, if you drew this up over here on this schematic side, it's going to end up somewhere else anyways. So let's put it where it needs to go so you don't have to search it out and copy and paste it. So if I follow this along, I go up to the AC here, and let's go now into the processor. So we Control, double-click, and it drops me in here. This is kind of like a mezzanine level. So if I want to go into this one here, I can again Control, double-click, and it'll bring me down to that level here. And again, if I want to jump up one, I just need to hold down my Control key, double-click on one of them, and it just brings me back accordingly. So it allows me to jump wherever I need to jump. And of course, if I'm kind of getting a little bit lost and I need to get back to the top here again, then feel free to go back to the Projects panel and click on the top-level design, and it'll get you there as well. So that's how you would navigate something of this nature, and hopefully you'll be able to do that fast and easy. Now, let's go on to the PCB side of things here. Okay, let's go here. I'm going to double-click on the Bluetooth Sentinel PCB dock. Okay. Now, first and foremost, the good news is this. Whatever the zooming and panning capabilities you've decided to take on in the schematic side pretty much will work on the PCB side, both in the 2D mode and the 3D mode. Okay, they will work. So my panning, if I right-click here and hold it down, my panning works. If I do a VD, it's going to put my whole document in there. If I do a VF, it's going to zoom me in a little bit closer. One of the things I'm going to mention here, not to get too nitty-gritty, but I think a lot of people don't generally like this white background here on their PCB. There's just traditionally been always a black or darker background. So I'm going to go into the Design menu on the top, and then at the very bottom, I'm going to go to Board Options. And once my dialog comes up here, there's a little checkbox that says Display Sheet. I'm going to turn that off, and now I don't have to have that glaring white background coming at me here. Okay. Now, there are 2 things we got to consider when we deal with the PCB side of things. One of which is the modes, and the other one's the layers. So let's talk about the modes first. Traditionally, there's always been two modes in Altium Designer. There is the 2D mode and the 3D mode. In Altium Designer 14, they created another mode called the board view mode because Altium added the capability of flex rigid. And as a matter of fact, if you look at this design here, this is a flex rigid design. You have an area of rigid and an area of flex. And so they need to be able to define it. So they created a new mode for that. So for me to get to those, I can do it one of two ways. I can use the hotkey, but I think it's better for me to show it to you in the menu. So under the View menu, you'll see that there's board planning modes. This is the new Mode 1. The 2D layout mode is you can hit the 2 key, and then the 3D layout mode, you can hit the 3 key. Now, if you are doing no flex rigid whatsoever, you'll probably never have to look at Mode 1. It's just good to know it's there. So if it looks like this here, then you can see that you're actually in Mode 1. You cannot do any placement in here, and you cannot do any routing in here. All you can do here is take your design and separate off what the different locations are for your design. So you can bring in a design that looks like this to begin with, just an outline. You can tell Altium to make your board based off of this outline, and then you can draw these demarcations to show which areas are the rigid and which ones are the flex. So that's what they would be doing with this. But again, for our purposes of navigating, other than the fact you might accidentally end up over here by pressing the 1 key, there's not much to do on this side. So if you do hit the 1 key, hit the 2 key, and that will bring you to the 2D mode. 95% of everything we do is going to be in the 2D mode. All your placements are done in there. All your routing is done in there. The other 5% is going to be the 3D mode. So I'm going to hit the 3 key. Okay? This is the most powerful feature of Altium Designer. And you will, by default, always see the board. So whatever board that you've got in here, you will see it. Now, in terms of the nice, pretty pictures that you have over here, that's completely dependent upon the library that your folks have put together. So if they've done a lot of work on their libraries, they will, you might see some really nice pictures here. Otherwise, you may just see some blocks. It doesn't matter. Really, the key thing here is that you do want to have some type of 3D representation for 2 reasons. Number one, Altium has a pretty phenomenal component clearance capability. It can handle both the vertical and the horizontal. So as long as you have the 3D bodies in there, it can check to see if there's going to be collisions. Secondly, and this is what made Altium, I think, really put them on the map, is that they bridged the chasm between the electrical engineers and the mechanical engineers, and that was through 3D. Because I can take this and I can basically save it off as a step file, send it over to the mechanical folks, and they can take a look at it. And then in turn, they can also send me things as well, and I can bring them in to see if we're going to have some collision issues, or they can at least provide me the accurate components so that I know that what I give them in the future will work for them because they've given me parts that I know are accurate. So that's what we've got. Nevertheless, in terms of what we're trying to do here, again, we're trying to zoom in and out. We can use our scroll. So I'm using my mouse to scroll in and out. Same thing we saw in 2D, same thing we saw in the schematics. You don't have to learn a new set of zooming. And then, of course, in addition to that, I can pan. So if I right mouse click and I hold it down, I can pan it around. Probably the only difference here is that if you want to turn this or look into the Z-axis, we can hold down our Shift key. So if you don't have a 3D mouse, this is the way you do it with the normal mouse. You would hold down your Shift key. You're going to get a bubble, and that bubble is going to show up where your cursor was prior to you hitting the Shift key. I'm going to right mouse click, and then I can start turning it around. Okay? And I can start moving it as I see fit. Okay? Once I've got it kind of turned around, I can always hit the 9 key, which will put it on a 90. I can hit the 0 key, which will put me back to basically a 0-degree turn. If I want to flip it over again, I could use my Shift key, hold down the Shift key, and then start turning the bubble by holding the right mouse click. Or I can go into the View menu here. And again, all these different things are set up for you to be able to navigate and zoom this. You can just flip the board. And of course, I can pan again here to bring it back to the center. And if you really turn it into hash, don't worry about it. Hit the 2 key to get back in the 2D mode, and then hit the 3D key to get back in the 3D mode, and it will kind of reset itself a little bit. So don't worry about if you put it in a really weird or an unusual location. Let me get back to the 2D mode, because there's quite a few things we want to talk about in there, because again, this is where most of the work is going to be done. All right, so we talked about the modes, but now we got to talk about layers. So in the 2D mode, we've got a number of layers that are available to us, and I think it's important for us to understand what these layers are doing. I'm going to hit the L key. The L key, so L is in Lima, is a very important key for us because it allows us to turn on or off tabs that pertain to the different types of layers that we have. What are these layers? Well, first and foremost, we've got our signal and our power plane layers. For this particular design, there's only 4 internal layers. Okay, pardon me, there's only 4 layers. There's 2 internal layers, but there's a total of 4 layers here. They used signal layers for this. They did not use internal planes. Now, a lot of people, what they do in Altium Designer, I think this is a good note for people just navigating through Altium, is that obviously in the past, if you had a ground plane or a power plane, you would declare those to be internal planes. However, there's more control over your copper when you use what's called a signal layer along with a polygon pore. So a signal layer is positive copper in the sense that, now, if you understand fabrication, put that aside for a moment because obviously they do most of their stuff as a subtractive process, and I don't want to confuse that here. What I want you to do is look at Altium Designer as saying, if I put down a signal layer, whatever I draw on that layer is going to be the copper that I'm going to get at the end of the day, okay, through the fabrication process. So what they did over here is they created basically 4 positive copper layers, all right? And then they use this thing called a polygon pore, and the polygon pore is a very powerful primitive in Altium Designer where you can basically draw its outline, and then you can say, hey, polygon pore, what I want you to do here is I want you to adjust yourself or pull back based on design rules that we have created. So I don't have to manually draw these things out. I just need to draw where my polygon pore is supposed to be, and it will pull back the copper based on the design rules that I've set up. Very, very powerful way of doing it, and that's what most people do now, is that instead of using an internal plane where it's negative copper, where by default the whole thing is copper, and now you've got to show places where the copper is supposed to be removed, it's a lot easier to work in positive copper and to use a polygon pore to manipulate it, and that's exactly what they did in this project here. So there's no internal planes that were declared. By the way, you cannot declare a new signal or internal plane in this menu. You've got to use the layer stack up menu for it. All right, so that's what we got for our copper planes, or pardon me, our copper layers. For our mechanical, now the mechanical are things that are there to allow us to write up information to assist our fabricators and our assemblers. And a lot of these mechanical layers should be coming from your library. And I think the key thing that I want to mention about this is that if you are going to, be careful about your libraries, you want to make sure that whatever mechanical layers are being dedicated, that everybody's doing the same thing. So for example, if you have one for glue dots, and maybe that's your mechanical 5, then make sure everybody's putting their glue dots on mechanical 5. Or if you have courtyards in mechanical 7, make sure everybody's putting their putting their courtyards in mechanical 7. Because if they're scattered all about, it's going to make it really hard for documentation purposes. Now, in addition to that, you can always use mechanical layers for, you can always open up another mechanical layer. In fact, I can bring these up and I can show you all 32 layers. So if I want to bring in mechanical layer 23, I certainly could do that, and I can use it within my PCB dock for this particular purpose. One of the questions that some of you are probably coming up with right now is you're probably saying, okay, is there an official specification, or is there a list of mechanical layers I should be using? And the answer is no. I'll put you this way, there's no official IEEE, and there is no specific IPC. And so as a result of that, you really have to come up with layers on your own. Now, in the Altium forums, they've had a lot of discussion about this. But what you're going to find is that what will work for one company will probably not work for you. Some of it may be overkill, or some of it's a situational type of thing where it's like, well, they're doing this stuff for the military. We're not required to do that. It's going to take too long. There's no value added to it. Why would we bother with it? So the only recommendation I'd make to you on this is that everybody agrees to what the mechanical layers are for your company, and they stick to it, and you'll be fine. Okay. Now, in addition to that, there are other special layers. There's top and bottom solder paste, and also top and bottom solder. Okay. These generally would be addressed one of 2 areas. Either going to be addressed in the library because there has to be a special modification made to it, or at the very end when you're trying to get your manufacturing files ready. I generally don't like showing these because it just adds to the clutter, and if I was doing a normal placement route anyways, I'm not looking at any 4 of those layers, so I'm going to turn those all off. There are a couple other special layers that they've got here, like drill guide and drill drawing. And quite frankly, I think this is a holdover because in the past, I don't understand why these don't become mechanical layers, but there may be something deeper about that. But you can turn those on or off. Again, I don't really need them while I'm doing routing and while I'm doing my my placements. The keep out layer is a useful layer. If designers do use it, it's because they want to keep routes from going into a specific area. And if they've turned it on and they've actually drawn on this layer, when you do the routing, and in Altium Designer, their smart router is it knows not to go through an area that's being blocked off in the keep out layer. So the way you can do the routing in Altium is that they do have an auto router, but a lot of the manual routing that you do is kind of like power steering. You still have to drive it from point A to point B, but they make it very easy for you to get there because you don't have to put a lot of effort into trying to make turns and stuff. Altium does a really nice job of kind of snaking its way through things as much as possible based on the rule set. So it does a nice job of that. And I would keep the multi-layer on because that basically represents your via holes and your through-hole pad holes as well. Your silks are represented here. They call them overlays. Any of the other things that you want to touch up or make different, you can. For example, if you don't like the gray background and you want another color, you can change the workspace color in this particular area here. My only recommendation is you can play with it all you want. You need to have contrasting colors or you won't be able to see the difference between the background and what you're trying to do. Also, we've got show hide. On the top here, I can put everything into a draft mode just to show you what it looks like. It looks like basically, I don't know why they don't call it vectors, but when you press OK, and I'll zoom on in over here, everything became basically a vector representation. And what's nice about this is it allows you to see what's going on underneath pads. So it's one way of taking a look at it. If I hit my L key again, I'll go to show hide, and I'll go back to all final. You can hide things here, but just remember, even though you've hidden them, they are still subject to the rules. Like, for example, some people will hide the rules, the rooms, they'll hide the rooms, which is good because sometimes it becomes a hassle. You click on something, it's always asking, do you want the room or do you want the part? And those rooms sometimes will work well hidden, but then you might get an error violation. You don't realize, well, why am I getting an error? Well, maybe you moved a part out of the room, but you can't see the room because it's hidden. So there's always advantages and disadvantages to this. I wouldn't do hidden for polygon pores. There are other ways to handle polygons. I'll talk about those in just a minute. For view options, the only thing I'll mention in here is the single layer mode. I'll show you how to use that. It's a very neat feature to keep in your quiver of different things to navigate through Altium. And then lastly, there's a new feature they've got in here called transparency, and this one's really slick. Now, Altium's messed with transparency type of stuff in the past. And the problem with that is that the graphics cards. Everybody had kind of a different graphics card, and as a result of that, sometimes it worked and sometimes they didn't. But now the graphics cards have gotten so good with their shader leveling. I mean, you can buy one of the lower end computers and it'll be able to handle it rather well. So I'm glad they added this back in, and what this is, actually not just added it, but they really enhanced it. So what you can do over here is that rather than shelve the polygons, get those out of there because they flood the copper on every layer and it makes it really tough to see what's going on, you can actually make them so they're more transparent. And just to demonstrate this, I already have the signal layers up here, so I can stretch these out here, and I'm going to hold down my Shift key to click for all 4 layers on the polygons, and I'm going to bring this up to about 80%. Okay, there we go, and I'm going to press OK. So 2 things are going to happen. I turned off my vector mode, and then secondly, I can see through all of these now because I put it onto the transparency. Okay, so I can easily see through all of my polygon pores. If you don't want to do that, another way to do this, or if you're using an older tool that doesn't have that feature, you can always go into Tools, Polygon Pores, and then you can shelve the polygons. And we can do that as well. Okay, and then you can see that all the polygon pores have been shelved. The one thing you do have to do prior to doing any type of manufacturing documentation is you do have to go back to Tools, and you go to Polygon Pores, and you can restore those. Okay, I'm going to leave these off here for a moment. What I'm also going to show you is the one I mentioned just earlier on, is that Shift-S, which is the single layer mode, and the multi-layer mode. So right now, by default, we are in the multi-layer mode. That means we see all the layers. Even though I'm on the top layer, this is the active layer, I can see all the other layers. Well, what if I just want to see the top layer by itself? Do I have to go into the L key and turn everything else off? And the answer is no. The simplest thing for me to do is to do a Shift-S, okay, not a Control-S. A Control-S will save it. But a Shift-S will bring me into single layer mode, so whatever the active tab is that I have available over here, that is what is going to be seen. So if I go to mid layer 2, for example, I just see mid-layer 2. If I go to mechanical 7, which has nothing on it, let's go to mechanical 15. Mechanical 15 has courtyards on it and its center points, so I can take a look at those as well. So that's another very nice feature just so I can see individual layers. I am going to go back and hit my Shift S again. Now, in many cases, you know, it's one thing to kind of look and view various layers, but a lot of times we're trying to find certain components, we're trying to find certain nets. So one of the easiest ways to do that is through the PCB panel here. And I'm going to click on that here right now. Bring this one up. So it's just called PCB. Here's a good example. I thought this might happen today. So going back to our little panels example, I did get that what I'll call glumming effect. And if you do get this, the easiest way to fix that again is to hold down my Shift key, and then I'm going to left mouse click and drag this out. Okay, so now they are separated out, and then I can basically redock this, and now I'm a happy camper. Here's my projects panel, and here's my PCB panel, and they're not split, or what I call glommed together. Okay. In the PCB panel, there are a number of different ways to look for things. They keep adding more and more to this all the time, but the two I'm going to show you that I think are the most important, and again, I recommend you play with all of them, but the two that I think you'll find useful is nets and components, and they work in a very similar fashion. So there are three regions that you see here. The first region are for classes, the second region here for the signals themselves, and the last one is for the individual primitives that make up each one of those nets. So in this case over here, we don't actually have any net classes. So when they designed this, they didn't use any net classes. And you may hear that term thrown around, what's a class? You don't have to worry about it too much other than the fact it's a nice convenient name or a bucket that you give to a bunch of other nets. You can also have a component class, which is a bucket of different components. Why would you use that? Well, in the design rules, which I'm not going to go into here today because I think that's more of a designer thing than a navigator's thing, but in the design rules, you can, instead of saying if this net or that net or the, or this bus, you can basically create a class. There's a way to define under design. You go to classes and you can define a class. And by doing that, now I can just say if it's in this class, then do X, Y, and Z. Or if in this class, the clearance is supposed to be X. And so that's what they're doing. Now in this case here, they didn't create any classes, which is fine. Now in a larger design, I think they would have created them. Now there's a default all class or all nets, and they always provide this whether it's for components or for the nets themselves. And when I click on it, I see all the nets that we have available. And you can see that as I'm clicking on each one of these things, it's doing a couple of things. First and foremost, it's masking out other things. It's also selecting these. It's also zooming based off where it's at, and it's also clearing what I did the last time about. So how do I control that? All that is actually done up here on the top. So if you're clicking on something here and you're not seeing this mask out, it's probably because it's in the default normal state. So if I click over here on S clock, you can see that it does highlight it, but it did not mask out the rest of it. The other thing that I can do is I can either select it, and a lot of times if we're selecting it, it means we're trying to do something with it. We're trying to do an edit to it. In our case, we really just want to highlight it, and so that's why I normally turn off the select, but I will also turn on the mask. You'll see why here in just a moment. Because if I select, let's say, SPI here, then I see it, but if I had my normal on, I wouldn't have a very hard time seeing it because there's not much of a difference between what this is and what the rest of them are. In fact, let me go back to normal and you can see that. Okay, so if I click on S clock again, I'm not even really sure what it's highlighted. Okay? And so that's why it's a lot better for me to go into the mask mode. But you can play with this all you see fit. Now, if I do have select, okay, and I've got my turn off my clear existing, you can accumulate things. So as I'm going about, it's actually accumulating all of these different nets. So if I want to grab a bunch of these nets and then make a change to them globally, there's ways to do that in Altium Designer. So a very, very powerful way to find nets in Altium. Second thing that we can do is we can do the same thing for the components, not from to editor, components. There we go. Now in this particular instance, there's a lot more component classes. Altium by default, for every single one of its design sheets, will create a component class for it. All right, it's just one of the default things it does when you go from the schematic to the PCB side. Do you have to use the classes? No, it won't complain about it, but they're available for you, and you can always remove them if you want. There's no requirement to have them. So, unless you're using them as a rule, or you're using them in a rule query. So let's click on power over here. Actually, it's maybe too big. Let's click on this microcontroller here, and you can see all of these capacitors that are associated with it. Same thing, as I click on them, they will highlight those things that are associated with it, right? So hopefully easy enough to use. Now, the grand question is, how do we take information from the schematic side and on the PCB side and bring it all together so that, for example, if I'm in the lab and I need to put a probe, or I need to look at something and I say, look, I've got this C15 over here, where is it in the schematic? I want to be able to find those things back and forth. And trust me, I remember there's a particular project I worked on. It was a very rushed project, and we had a situation where we did the schematics. We had to outsource the PCB documents to a third party, and we could not see it. They would, the company I was working for would not allow us access to the PCB tool. It was only allowed for those people who were in what they call the Design Resources Group. So everything we had was a printout, and I couldn't tell you how long it took us to match up something on a schematic to the PCB, and on the PCB on the schematic. So what we can do, what took us merely 20 to 40 minutes to just find one probe, we can now do in less than 5 seconds. So how do we do that? Well, first and foremost, I'm going to split this up. I'm going to right-click on this document in what they call the document bar, and I'm going to split vertical. So my PCB is on one side, my schematics on another. And by the way, I should mention here that even though we see both editors, only one is active at any given time. So that's why if I click back here on the PCB editor, you notice that the PCB panel comes up, and when I click on the schematic, it disappears because the PCB panel has nothing to do with the schematic. So I do see both of them, but only one's active at the same time. I'm going to bring up a tool called the Navigator panel. And the Navigator panel in the bottom right corner is under the Design Compiler. I would have thought it'd be under System, but they actually put it under Design Compiler. I'm going to click on that, and I brought up the Navigator, and now I'm going to go dock it. So I dragged it in. It's now docked. It has nothing in it. So in order for us to use this, I have to compile the project. So clicking back onto my Projects panel, I'm going to right-click on the PRJ PCB name up here, and with Bluetooth Sentinel.prj PCB, and I'm going to compile it. And once it's done compiling here, I can go back to the Navigator, and now I have a net list that represents what's going on in my design. I'm going to click on Flatten Hierarchy because it shows me everything. And I've got all of my components here, and I've got all of my nets here. If I want to click on, for example, C5 or C14, I'll show you what this means here in just a moment, it will automatically jump me to where it is here on the design, on the schematic side. So if I want C9/C8, then I can find that here as well. Now, how does that help me on the PCB side? If I hold my Alt key down and I click on, let's say, for example, C6, C5, it not only found it here, okay, it also found it here as well. Now, you may be asking yourself, what happened over here? Why is this C5 and this one's over here C6? There was probably a back annotation that was done. All right, and Altium can track that information. I think this would be very confusing if this was on paper, and I'm not sure I'd really do this kind of practice. You can obviously take everything that you've got on your PCB side and push it over to the schematic side. There's one little exception when it comes to multi-channel, but I don't want to divulge to that too much. But the idea over here is that Altium can track this. So on this side here, this is C5, in parentheses C6, and over here we do see the C6. So it's one way to find things, and I can do that, by the way, for not just for the components. I can certainly do that for nets as well. So if I hold down my Alt key and hit PB7, for example, it jumped me to not only the location of the schematic, also here on the PCB as well. Another tool that's very useful, so if I don't want to set this all up or I need a quicker answer sooner than later, and by the way, as soon as I actually have a PCB, by the way, if I don't have a PCB, obviously this isn't going to work. Oh, by the way, here's a situation where even if I click off of it, it's still masked, so I'll hit at the bottom right corner. Okay, another tool that I've got, and it works either way, and I'm going to start off on the schematic and I'll jump to the PCB side after. It's a little stick of dynamite up here called a cross probe, and if I click on it, it basically gives me a cross here, and if I want to know where something is, it's just a matter of clicking it on my schematic or whatever the active editor is. I click on it and it'll show me exactly where it is. And you can see that it jumped over to the bottom part of my PCB. Same thing for U2A over here. Well, actually, it's the same one. It's just because these are split up. But what about C16? So because I hit the pin, I can see it over here. Can I do it on the PCB side? Yes, I can. I got to click on the PCB side first. I'm going to clear my mask, and then I'm going to use the stick. You may have not noticed, but this menu is actually changing. So this is now the PCB menu. So if I click between the two, there's very little difference that you can actually see. But I'm on the PCB side. I'm going to hit this stick of dynamite, as I call it, and I'm going to do, again, a cross probe, and I'm going to go for X2. Okay. Oh, there it is. And actually, in this case here, It's a little thing from Altium. You got to keep in mind when I'm doing a cross probe on the PCB side of things, it's a little more difficult for Altium because there's obviously multiple schematic sheets. It did find it, but it brought it over here on this side. I just dragged it over, and here it is. There's X2. Okay, so it will find it, and it works either way. One mistake that a lot of people make quite often is that they'll start this in a particular editor. They'll have a split screen. So let's start this again. Let's say I want to go for this U3. So I click on U3, and it brings it up. You can see that here. Oh, I found it, and I start scrolling off because I'm still in the mode to select things. So I got to right-click to end that mode, and then I can click over here and take a look at U1/U3. So there's the other way to do it. Lastly, there's one other thing, and it tends to work better for initial placements more than anything else. There's another tool. It's called Cross Select, and it's under Tools, the Cross Select mode over here. And what's really useful about this one is that when you go from the schematic to the PCB side, a lot of times well, pretty much every single time at the beginning, all of the components are going to be stacked on the bottom right side of the PCB board, and then you got to drag them over as to where you see fit. As long as this is turned on, so you need to have this little blue box over here turned on the schematic side and on the PCB side too. So I clicked once here. Under Tools, I got to have the Cross Select mode turned on here as well. What I can do is if I select something here, I'm not sure if you saw it or not, but when I selected it here on the schematic, it also got selected over here on the design as well. And that's really useful because, for example, if I wanted to keep all of these together, for example, like on my design, and I did this, all these would now be highlighted, and I could drag those all at the same time in a location, because I'd be under the premise that, hey, if it was drawn in close proximity in the schematic, it's probably in close proximity in the PCB design as well. So those are different ways that you can navigate it. So with the time I got left, I want to talk about subversion. And get onto that one there, because I think there are people in our audience today who are kind of curious about that. So I'm going to do a file close. All right. Actually, the easiest way for me to do this is to do project, right-click where it says PRJ PCB and close project, and this will close everything out. I'm not going to save anything I've done today, so I'll press OK. I want to mention this first and foremost. There is something that's built into Altium called subversion. That is free of charge. It is a freeware tool. It is not the vault. Okay? And then there's always the question of what's the difference between the vault and subversion. It's really this. The vault is a production version control system. What I mean by a production version control system is that you have a set of files that you're going to send out for manufacturing, and those are the files that you want everybody to refer to, and that they are not to be touched or modified, and if they are to be touched or modified, they would be a different revision. That's what the Altium Vault is very good at doing. Okay, in the Vault itself, and I don't have it set up on this machine here, but the idea behind the Vault is you declare a rev, you have an empty box, and then you push your entire design into that box, that rev, and if you need to make a change to it, you can dump the information out of that box, but you have to create a new rev in order to make those changes. The subversion, or SVN, they're basically synonymous with each other, subversion, SVN, is what I call a prototype version control system. It is extremely useful for those people who are doing the design because you can save to it as many times as you want. And as a matter of fact with subversion, its power is not behind the revision number. Its power is behind the comment that you put in it. And that the more you save to the head revision, the more tracking you do, you have more granularity. So if you go down a bad path, you can read through all the comments because you kept checking it in, and then you can say, okay, I need to make the head revision again, and let's go off on a different direction. So that's just the difference between the two. If your company has already set up subversion, then there's one thing you're going to have to do here. You're going to go into DXP, and you're going to Preferences. And in DXP Preferences, you got to go under Data Management. There is two things I'll mention. Under version control itself, you can see that the subversion is already turned on for you and that you're going to use the built-in subversion engine. Okay. If your company has used another one that is something different, or they've got something a little bit more elaborate, you may have to get some information about how to hook into that. Okay. Otherwise, you can leave this well enough alone. Then the second thing is that you need to tell Altium where to find information. Where is this repository that everything is kept? And so you could connect to that, and you'll just get the information here, and you can go about, and you can fill it in, and you'll be able to connect to it. All right. The other thing that you're going to need to do, and let's go back over here to the operating system for a moment, is that you need to create something that's called a workspace, because we never work in the repository. We check things out of the repository, we make changes to them, and then we have the option to push things back into it. But we never actually work in the repository itself. So we need to basically get a copy of it. So I'm going to do a File, New Folder, and I'm just going to call it Workspace. You can call whatever you want as long as you remember the name of it and where you're going to put it. All right. And I will go into this new thing called Workspace. I'm going to click once here so I get this highlighted, and I'm going to do a Control-C because I'm going to need it here in just a moment. Now in Altium Designer, I may have this whole link set up, but obviously I got to get to it. So I'm not going to do a File New here. What I'm going to do is I'm going to do a File Checkout. So I'm going to click on File Checkout. It's going to say, hey, which repository you're going to use, and even within the repository there could be different project folders. All right, in this case I just have one of them, and I would highly recommend there to be different project folders. Some companies, they create a different repository for every project. Some companies will have subfolders under one repository. It can be done either way. Okay, and then the key point is, where am I going to check it out to? So I'm going to highlight this and do a Control-V, and then I'm going to press OK. And so now it's going out to the repository. It has pulled it in, and this has now been all saved to my local directory. Let me bring that up here so you can take a look at this. So here's my workspace, and you'll see all these things in here. Now, if you don't see the check marks, that's not a bad thing. Okay. The reason why I see these is because I also have a tool on my computer called Tortoise, and it's another way for me to look at the repository without having Altium available. So if I can't use Altium, I can always look at the repository through Tortoise, and because the Tortoise is basically a part of the Windows file system, it basically embeds itself. It's not a separate tool. It actually embeds itself in the menu command for Windows Explorer. Then I can use it accordingly. So that's why I see these little icons here. You'll also notice the .svn. This would be a hidden folder if I turned off hidden items. Right, there it goes. But not to worry about that, because again, we're doing a navigation aspect of it. What's really nice about this, however, is that now that this is a copy that you have on your own desktop, you can play with this to your heart's content. And even if you accidentally somehow got it back into as the head revision, whoever's doing the administration could easily restore the true head revision to it. So if we open up anything over here, and we can take a look at it. Again, we're not working the repository, we're working local to what we've got. If I was to accidentally move something here, okay, and I accidentally saved it, no biggie, because it's local to my own directory, you will see an exclamation point over here. And it just means that you have a date that's newer than what's in the repository. So if you're just looking from a navigation point of view, these things will probably change over time, especially if you've gone to lunch and then you want to do a refresh. And by the way, it doesn't do an auto refresh. The key thing I'd recommend is you right-click, go to version control, and you would go into a refresh here, and it will check the statuses. And sometimes you'll see an orange status saying, hey, you're out of date, which would indicate that somebody's checked something in. All right. And if somebody's checked something in, again, because we're in really a look mode and not a do mode, we can right-click over here under version control, and the update would be available to us. And that means take whatever's from the repository that's latest and greatest and bring it down to our local directory. Okay. If you're interested in this, there's a couple of there is a particular video I did. I believe we did it either as 9.connects or I did it with a friend of mine. You'll hear my wonderful raspy voice. Regardless, there's a video that goes into great detail about how to set up subversion and some of the things I talked about here today, and how you'd use it really from a user's perspective as well. So take a look around on the internet. I think if you type in subversion and Altium, you should find it rather easily. So that's what I've got here at this point in time, and I wish you the best for this upcoming year.